Hi everyone, I'm Jackie, and today in this video, I'll be giving my June 2024 SAT predictions. This is based on my personal exam analysis of past official exams, also feedback from students of their past digital SAT exams. So let's, per usual, jump right into it. So first things first, a really common trend that's been on the past few digital SAT exams is factoring. There's usually one or two or maybe even three problems regarding factoring. So let's just check this problem here. Okay, so for example, this is an easier one. I'll be going through all the difficulties. One of the factors of 2x cubed plus 42x squared plus 208x is x plus b, where b is a positive constant. What is the smallest possible value of b? So first, I can see that each term has a common term, x. So I can factor out that x. And also I notice that all of the coefficients, they're even numbers. So I can actually factor out 2x directly. And in doing so, that will give me, so 2x, then this would be x squared in parentheses, plus 21x, and then plus 104. Okay, so we can see here I just need to factor out the quadratic basically. And remember what you can do is I look for the factors of 104. So two numbers that when I multiply them will give me a 104. And when I add or subtract them will give me the b value of 21. So let's just go ahead and list out all the factors of 104, which is 1 times 104, 104. 2 times 52, also 104. 4 times 26. And also 8 times 13 is 104. Okay, so looking at all of these, if I subtract one or add one, that's not going to give me 21. Neither is 52 plus 2 is 54. 52 minus 2 is 50. No. This one also. Minus, that could work. 8 plus 13, that equals 21. And 8 times 13 is 104. So that definitely checks. So then I could just factor, this would be x plus 8 and x plus 13. And remember it says this is x plus b, so this could be x plus b. This is x plus b. Always go back, read the question. It says, what is the smallest possible value of b? Well, that would be 8. And therefore, that's the answer. Okay, so that was an easier one. An alternative way to solve this, just to show, because you can also use your Desmos calculator. So here I've already typed in the equation 2x cubed plus 42x squared plus 208x, and I can see where the x-intercepts occur, negative 13, 0, negative 8, 0, and 0, 0. And we can see, remember, if I were to factor, that gives me x plus 13 is equal to 0, x plus 8 is equal to 0, 0 equals 0. So I can also see the solutions this way too. That could maybe be a little bit faster, depends on you and what you prefer. But knowing both ways can be helpful. Okay, so continuing our factoring journey. Okay, so this one, which of the following expressions is our factor of 3x squared plus 20x minus 63? So likely, just looking at x minus 9 and 3x minus 7, I'm inclined to think that in some way they can help me form or like help me to factor out this expression here. So I can do that. And I can do that approach. Let's factor and see what happens. Okay, so to do factoring where I have a coefficient in front of x squared, what I want to do is I want to find two values when I multiply. So remember, this is ax squared plus bx plus c. So it's two numbers that when I multiply a times c together, so in this case 3 times negative 63, which is equal to negative 189. And I'm looking for when I sum, will give me the sum of B, so 20. So I'm looking for two numbers. When I multiply them together, will give me negative 189. And when I sum or add or subtract them, will give me positive 20, the B value. So next we need to look at all the factors of 189. The factors would be, so 1 times 189, 3 times 63. We just already saw that. There's also 7 times 27. I think that will be the winner. And there's also 9 times 21. But I can see 27 minus 7 will give me 20. So I can get my B value. And then 7 times 27, or times negative, will give me negative 189. Okay, so I found my winning pair, and now I need to factor and put it together now. So to do that, I'm going to factor 20 out of the 20x. So just rewriting, this would be 30x squared. Remember I said my winning pair is 7, negative 7, 27. So basically plus negative 7 plus 27x. And then I'm going to put minus 63. Just to show all the steps here. Now I will distribute. So then I have 3x squared, minus 7x plus 27x minus 63. So now I can see that I have two groups essentially. So like I want to look at these as group 1, group 2. And then I want to find the greatest common factor of each group. So in this case, for 3x squared minus 7x, that would just be x, and then 3x minus 7. And then for 27x minus 63, the greatest common factor there would be 9. And then this would become just 3x minus 7. Oh my goodness, and we see how I have 3x minus 7 in both of them. And then final step would be to factor the polynomial by factoring the greatest common factor, in this case 3x minus 7. So basically I have the x plus 9 together, so this is 3x minus 7 and x plus 9. And if I expand that, I can see that will give me 3x squared plus 27x minus 7x minus 63, which will become what we have above here. So I found out my correct factored out expression, 3x minus 7 and x plus 9. So 1 doesn't work, it's only 2 only, and that's the answer. So I know that was longer, more of a process to go through. The alternative method is to use Desmos. So if I am to use Desmos, I'm basically looking for where the x-intercepts are. So go ahead, we'll type that into Desmos. I've already done that here. And then I can see, zooming in, one of them, it's here, negative 9, 0, x plus 9 equals 0. And the other one is here, 2.3330, which was our winner. Because remember here, 3x minus 7, if I set it equal to 0, I get that 3x equals 7, x equals 7/3, which is equal to 2.333. So that could be quicker, checking on Desmos. It's also good to know how to factor too, because you're going to see very soon that Desmos won't always help me. Oh my goodness, look at this problem. I heard that a very similar problem was on May 2024 SAT. I think it was most missed question, so definitely a good question to know. So let's take a look. This one, 34z to the 14 plus bc to the 7 plus 70. In the given expression, b is a positive integer, if qz to the 7th plus r is a factor of the expression, where q and r are positive integers, what is the greatest possible value of z? So here I can no longer plug this into Desmos because I have two variables. Okay, so what I'm going to do is factor. Okay, but so just to be methodical with this problem, so first, like, let's look at what's given. So given, I know b is a positive integer. So b is a positive integer. These are facts that will help me. QZ plus R, so QZ to the seventh plus R is a factor. Okay, and also Q and R are positive integers. Okay, so B is positive integers and Q and R are also positive integers. So then from there, let's just try to see. So I know that one of the factors is QZ to the seventh plus R. And I know I want to get this to Z to the 14th, right? So I can say that Z to the seventh and then multiplied, I'm going to put C. So C is just some constant that I need to solve to get, well, to solve this expression. It's just an unknown constant right now. And you can see if this would all be equal to 34Z to the 14th plus BZ to the 7th plus 70. So let's go ahead and expand here. So this will become QZ to the 14. Oh, looks close to what I want. Then here, I would have like QC Z to the 7th plus RZ to the 7th plus RC is equal to 34 Z to the 14th plus B to the Z, the 7th plus 70. Okay, so now look at the coefficients. So here I have Z to the 14th, Z to the 14th. So therefore, I can see that Q is equal to 34. Okay, next, also, I'm going to need to factor a little bit here. So have a common term. Each of these have Z to the 7th in them. So that would be Z to the 7th and QC plus R. And then I can see that that's what B is equal to. So B would be equal to QC plus R. So B is equal to QC plus R. Okay, and then my final part of the expression, RC, must be equal to 70. Okay, so now I have all my equivalences. So knowing that, let's continue the journey. Okay, so remember I'm asked for the greatest possible value of B. And I know that B is equal to QC plus R. Okay, so I could rearrange this a little bit, like R is equal to 70 over our C value. And I know that B is equal to QC plus R. I know Q, it's 34, so I can plug in the 34. C, I don't know, and I know that R would be 70 over C. Okay, so then going back to our known facts, our given facts, remember it says that B is a positive integer. So the only way in which B is going to result in a positive integer is if I make C, it must be 70. Why? Because it's the only number, the greatest number that could be C. Like, yes, C could be 1, 2, any other even number, etc. However, the largest it can be is 70 and still be the largest integer. So I can make C 70. And then I can just do B is 34 times 70 plus 70 over 70, aka 1, which 34 times 70, it's 2,380 plus 1, and therefore the largest possible value that b could be is 2381. And that would be the correct answer for this one. Okay, so here, I can't use Desmos here to solve. It's really knowing factoring really well, and also being familiar with equivalent expressions, which we will also look at next. Wasn't that amazing? Okay, so continuing our journey. This one's very similar to the one we did a couple of problems ago. So again, I can like use the terms here. And remember, like I have 4x squared plus 31x minus 45. So I'm looking for two values that when I multiply them together, I'm going to get, so a times c, which would be 4 times negative 45, which is negative 180. And when I sum these values that I need to find, will give me 31. So again, I can list all the factors of 180. So 180, 2 times 90, 3 times 60, 4 times 45, 5 times 36, 6 times 30, 9 times 20, and so on. However, I already found two numbers. If I were to subtract 36 minus 5, that would give me 31. So I found my winning pair. Okay, so next I'm going to factor out the x now. So now I write 40x squared plus 31x, right, minus 45. Now I know, because I found my winning pairs, that would be 4x squared, like plus minus 5 plus 36, factor out the x, minus 45. Okay, so now I'm going to have my two groups when I distribute the x. So I have 4x squared minus 5x plus 36x minus 45. And then I have my two groups, right? I have my 4x squared essentially. And then I have my 36x minus 45. Now I need to find the greatest common factor of this group, which looking at them would be 4x minus 5. Okay, so here though I would factor out the x, so that would be 4x minus 5. And then also here I'd be adding, and this would be 9, 4x minus 5. And then final step, I can see that I have my 4x minus 5 on each of them. So it's going to be x plus 9 multiplied by 4x minus 5. And then we can see once again, so x plus 9 is a factor and 4x minus 5. So it is only 2 again. And of course, these one where there is just one variable x, I can always maybe shortcut, use Desmos and solve. You can see here I mapped it here. I check what the x-intercepts are. -9, 0 is one, and the other one's at 1.250, which would be 4x minus 5 is equal to 0, because that will give me 5/4. Okay. Isn't that amazing? So one last factoring one. So if you want to go to fast forward to the other concepts I think will be covered, go for it. But remember, all these questions have appeared on past official SAT exams and were really great concepts to know. Okay, so final factoring problem, then we'll move on to another amazing concept. So which of the following expressions has a factor of x plus 2b, where b is a positive integer constant? Okay, so this one's a little bit more complex because now I have x and another variable b. Okay, so first, let's see. I know that one of them is going to be x plus 2b. Okay, so for example, let's just check a. X is 2b, And then here, this must be 3x because I want this when I multiply to become 3x squared. And then it's going to be like plus some constant k, and then it's going to give a positive integer constant. Okay, so first let's expand this. When I expand, I would get 3x squared plus kx plus 6bx, and then plus 2bk. Okay, I remember this would all be equal to my expression in answer choice A. So we can see 3x squared is equal to 3x squared. Here, I'm going to have to factor out the x. This would be k plus 6b. And then I can also see that 2bk is going to be equal to 18b. So 2bk is equal to 18b. I can divide each side by 2b, and I get that k is equal to 9. So I know k is equal to 9, and then I also know here that my k value, so my k value, or like the k plus 6b over here, this is going to be equal to 9. How do I know that? They each have x in front of them. Okay, so then it's like, all right, so k plus 6b is equal to 9. I now have solved for what k is, so I can now substitute that in here. So that'd be 9 plus 6b is equal to 9. I get 6b is equal to 0. So this will give me that b equals 0. However, I want b to be a positive integer constant. Okay, so I should go through and check out all the answer choices. However, there's kind of like well, there is a shortcut because I can see each of them, it's going to be x2b plus 3x plus k. And then I just set them equal to the expression here in b. So like I know that, just to show, this expands to the same exact expression above, right? So xk plus 6b, and then plus 2bk. And this is going to be equal to answer choice B, 3x squared plus 24x plus 18b. Oops, 18b. So again, like I know 2bk, it's 18b. This is going to be true in all the answer choices that I'm testing. So 2bk equals 18b. Again, k will be equal to 9. And then here, I have my k plus 6b will be equal to, in this one, it's equal to 24. 24. And then I just need to solve again. So I do 9 plus 6b equals 24. So 6b is equal to 13, 15, sorry, 15. But then b 15 over 6, that's a fraction. So it's not an integer. But you can see, so like for c, I can say, like basically all I have to do is take k plus 6b and put that equal to 30. And then k is always 9. And then this one would be 6b is equal to 21. This will also give me a fraction. So therefore it must be d. And then for d, it would be k plus 6b is equal to 39. So again, like 9 plus 6b equals 39. 6b is equal to 30. B equals 5. It gives me a positive integer constant for b. So therefore answer is D. But you see, like I didn't have to go, like once I recognized the equivalences in answer choice A, I can just take the expression and set them equal to the b value in each of the answer choices to solve. And see which one gives me a positive integer constant, and then I have the answer. Amazing, right? Okay, so here we've been doing a lot of equivalent expressions. These ones involve factoring, and they could on your exam too, but just to do a couple more of these. So this is from older SAT exam. However, I've seen this concept come up so many times on digital SAT, it's worth going over and mastering. So again, what I'm going to do is expand the brackets in this expression. So here I have abx squared plus 7ax plus 2bx plus 14, and this is all equal to 15x squared plus cx plus 14. Just like we've been seeing, I can see these each have x squared in front. I know AB is going to be equal to 15. I can see 14 is equal to 14, nothing to do there. And these each have the x in front. So this value here, 7a plus 2b, is still going to be equal to c. 7a plus 2b is equal to c. Okay, I'm also told a plus b is equal to 8. Okay, so there's only two possibilities. Well, one possibility that will result in a times b being 15 and a plus b being 8. That's 5 times 3. But I don't know if a is 5. It's either a equals 5 and b is 3. That's one possibility. Or a is 3 and b is 5. It's one of those choices. I don't know which one it is, and that's why there is two possible answer values for C. So now that I've defined these, now I just need to go back and substitute. So this could be 7 times 5 plus 2 times 3 for B, 35 plus 6, 41. So that's one possibility. Or there's the possibility that A is 3 and B is 5, in which case this would be 21 plus 10, which is 31. And we can see C is 41 or 31, and that's answer choice D. So just get really confident with equivalent expressions and factoring because it comes up, it seems like on most SAT exams. I expect that you'll see it on the June SAT. However, let's just do one more for good measure. Okay, so this one here, the expression 9x minus 28 times 15x plus 4 is equivalent to the expression ax squared plus bx plus c, where a, b, and c are constants. What is the value of? Okay, so just like the previous problem, I'm going to expand out the brackets of this expression here. So 9 times 15, that's 135x squared, 9x times 4, so plus 36x, negative 28 times 15, it's minus 420x, and then negative 28 times 4 minus 112, and this is all equal to ax squared plus bx plus c. And then from here, 135x squared, simple or combine the like term, so combine the x's, so this would be minus 384x minus 112 is equal to ax squared plus bx plus c. And then again, I can see like the a value must be 135. And then the b value, what I'm asked for, must be negative 384. And therefore, that's the answer. I can stop there, but for learning purposes, C would be equal to negative 112. Okay, so I hope you got a good grasp of factoring and equivalent expressions on this. Let's go into the next concept that I think will be on digital SAT, which is sum of the solutions and product of the solutions. So yes, there is a shortcut to a couple of these problems. These I've noticed have appeared on December SAT, March SAT, May SAT. So high chance that they would also appear on June SAT. Let's take a look. So first, this one we can apply a shortcut since it's a quadratic. Okay, let's see. So in the given equation, a and b are positive constants. The sum of the solutions to the given equation is k for a plus b, where k is constant. What's the value of k? Okay, so remember this shortcut. If you ever see sum of the solutions for a quadratic equation, it's negative b over a. Okay, so let's see what the b value would be here. So b would be equal to like negative 16a minus 4b. And my a value, it's just 64. So negative um, 16a minus 4b becomes positive again. So basically this would be 16a plus 4b over 64. So negative b over a, and that's equal to k for a plus b. Oh, on the left-hand side, I can factor again. Remember, factoring, it's super important. So factoring, I could factor out this, so it'd be 4a plus b over 64, and that's equal to k for a plus b. And then I can see these equal each other, so therefore k will be equal to 4 over 64, which reduces to 1 over 16. So 1 over 16 equals k. That's also equivalent to 0.0625. Okay, so that is one shortcut that you can do for the exam if you have some of the solutions, negative b over a. So lately though, you could see this on your exam. However, lately they've been asking for some of the solutions or product of the solutions for polynomial. Okay, so here, this looks more like a polynomial function. Okay, so here it gives me an equation and it says in the given equation, u is a positive constant. The sum of the solutions to the equation is 9. What is the value of u? Okay, so first of all, the sum of the solutions for these equations, it's always where the x-intercepts are. Those are the solutions where the function is intercepting the x-axis. So therefore, I can take, for example, 7x squared, set it equal to 0. What does that give me? That x is 0. That's one solution. Another solution, 4x minus 13 equals 0. 4x equals 13, and x is equal to 13/4. That's another x-intercept, another solution. And the other one, 4x minus u, is equal to 0. So then 4x is equal to u, and x is equal to u over 4. Okay, so now I can take all these solutions. So 0 plus 13/4 plus u over 4, and they're all equal to 9. That's u. Okay, and then to make my life easier, I'll multiply each side by 4. In doing so, this will cross out the denominators here. So I have 13 plus u is equal to 36. Subtract 13 from each side, and that gives me my answer, 23. Okay, so you can see I can get what the sum of solutions are, um, basically getting what the x-intercepts are, sum them, set them equal to whatever they tell me to, and then I also get the value. So be sure you're familiar and feel confident with this concept. It doesn't matter that there's an extra additional variable here. Let's look at another one. Okay, so this one. In the given equation, k is a positive constant. The product of the solutions is 77. What is the value of k? So again, I'm going to find what the x-intercepts are. So one would be 4x plus 7 is equal to 0. So one of them will be x equals negative 7/4. Another one, x plus the square root of 4k plus 7 is equal to 0. So x is equal to negative 4k plus 7, square root. And the other one would be x minus the square root of 4k plus 7 is equal to 0. And then this is basically equal to x is equal to 4k plus 7, the square root. Okay, so I have my 3 solutions so that it intercepts the x-axis 3 times. And then next it says the product is 77. So now I'm going to multiply these together. So negative 7/4 times negative square root 4k plus 7 and then times 4k plus 7 square root. And this is all equal to 77. Okay, well, fun fact, if I multiply two square roots that are the same, for example, square root of 2 times square root of 2, it's equal to 2. So why am I showing that? Because these two expressions, when multiplied together, will just become 4k plus 7. Also, I have the two negatives, negative times negative, it will become a positive expression. So basically, I can just express this as 7/4 multiplied by 4k plus 7 is equal to 77. Okay, now I want to remove the 4 from the 7/4, so like remove fractions where you can. So I'm going to multiply just by 4. So here it will cancel, and then I'm left with 7 4k plus 7 is equal to 308. Divide each side by 7. So I get 4k plus 7 is equal to 44. Yes. Next step, subtract 7. So I get that 4k is equal to 37. So k is equal to 37/4, or 9.25. And we can see those would be my answers. You can type in either one on the exam. Okay. Next concept that I foresee on June SAT exam comes up on almost every single exam is no solutions. So you're probably, if you've been practicing like the Blue Book exams, you've been practicing the practice questions on College Board, you've been doing Khan Academy, you probably are familiar with this concept. However, they've been putting slight twist on the problem on the exam by adding in an extra variable. Okay, so example, negative 5x plus 15rx is equal to 30 or 135. Okay, important. Equation has no solution. It's a linear equation. So no solutions means that they're parallel lines. Because parallel lines never intersect, they have no solution. And this means that their slopes are equal. So there's two ways to go about this, but if you're really good with linear equations and this concept, I can just take the given equation and move the negative 15rx plus 135. And then I can see their slopes must be equal to each other, right? So that would mean that negative 5 is equal to negative 15r, because I'm referring to y equals mx plus b linear equation. So the ones with the coefficient x here, or like x in front of the coefficient, will be the slope. And then I just have to set negative 5 is equal to negative 15r divided by negative 15. And then 1/3 would be equal to r. And that's the answer. Alternative way would also be like, when would an equation have no solution? If the two sides of the equation don't equal each other, they give an impossibility. So I could have also have been like, okay, so negative 5x plus 15 rx equals 135. I can factor out the x, do 15r, minus 5 equals 135. And then I can set it equal to 0. Negative 5 plus 15r equals 0. And then that would give me r equals 1/3 as well. So same thing. And like basically, if I went in and plugged in 1/3 for r, it would tell me that 0 is equal to 135. That's impossible. That's a non-solution. Personally, I prefer this way, and that's the answer. Okay, and then, oh my goodness, let's look at this classic. One of the equations in the system of two linear equations is given, n is a positive constant. The system has no solution. which equation could be the second system of the equation? Parallel lines, and therefore they have the same slope. Okay, so I mean, first thing I would do personally is to rearrange the equation. I would put everything in terms of y in slope-intercept form, so y equals mx plus b. And this would give me, so for example, -31 is equal to -31x plus 62n. Divide everything by -31, and I get that it's x minus 2n. Okay, so like I'm looking for the same slope, but there should be a different y-intercept. So um, looking at the answer choices, like I know if I move this over to the other side, it will be negative, and then I'm going to be dividing by +3, and I can't have a negative slope. It needs to be positive. So I'm going to eliminate the ones with, it's got to be A or D. Okay, so then let's look at A. If I rearrange A, this will become -3y is equal to -3x plus 6n. Divide everything by -3, so y is equal to +x minus 2n. Which this is, looks good here. However, this is infinite solutions, and be very careful with these ones because usually one of them, it's a trap, and is infinite solutions. Infinite solutions means they're the same exact line, so they have same slope and same y-intercept, which is not what we're looking for. I'm looking for no solution. Okay, so therefore it must be D. But just to show, -3y equals -3x plus 3n. Divide everything by -3. So I get that x minus n. And then I have same slope, but different y-intercepts. And therefore D is our winner. Isn't that amazing? Okay. So I know I go on in these concepts, but they're just important and I want you to do well on SAT. So I'm going to continue. Another concept that I think will appear on digital SAT, percents. Percents, they do appear on most exams, and it's easy to mistake them, to do a misstep and get them incorrect. So even though they might seem easy, they are frequently missed questions. So always read them super carefully. I want to go over a couple with you in case you get similar ones on the exam. Okay, so this one, the positive number A, it's 2,800% of the number C. Okay, so to put that into proper terms, so we can always write percents over 100. So this would be 28 over 100. So I can see that's just equal of the number C. So A is equal to 28C, like that equals A. Amazing, right? And then C is 20% of the number B. 20%, that's the same as 1/5 of B. So I know what C is, and then I'm asked, what is the value of A minus B in terms of C? Okay, so I'm going to here multiply each side by 5. So I get that 5C is equal to B. Because now I have both A and B in terms of C. And then if I do A minus B, just substitute them in. So this would be 28C minus 5C, which is 23C. And that looks just like 23 for correct choice A. Isn't it amazing? Okay, so I've seen a couple of those come up on the exam. Be familiar with them. Then there's always similar ones like these. So when a collection of books is sorted, 52% are nonfiction, and the remaining books are fiction. The remaining books would be 48% because 100 minus 52, it's 48%. So of those that are fiction, 75% are Westerns and the remaining fiction books are romance. Okay. So if they're blah, blah, blah. So first, let's say there's like T, total number of books. So I know that the remaining books are nonfiction. So like 0.48 of the total books are fiction, right? Okay. So 75% are Westerns and the remaining books are romance. If there are 933 romance books in this collection. Okay, so I have to see if 75% are Westerns, that means that 25% of these would be romance, right? Okay, so then I can do romance would be equal to like 48% of the total books multiplied by 0.25% for the romance books. That's equal to like 12% of the total. Okay, so 12% of the total are romance books. And then I can simply take this if there are 933 romance books, so 0.1 or 12t is equal to 933. What is the total number of books in this collection? Divide each side by 0.2. That will give me 7,775 is equal to total books. Isn't that amazing? Okay, so just for these ones, they give so much information in them, it's easy to make a mistake. You also saw me go back to the problem a couple times to read carefully. So go back, read carefully, make sure that you're setting everything properly so that you get the question correct. Okay. This is just another number one, but you can see similar concepts appear on different exams. I'll solve this one too. So the speeds of particles A, B, and C are A meters per second, B meters per second, and C meters per second, respectively. So if the speed of particle A is 6,600% of the speed of particle C. So remember, I just put the percents over 100, and that's basically 66 times C, which is equal to A. And then below, and the speed of particle C, so C is equal to 0.004 over 100 of particle B. Okay, which would be, so I want to put this again, like I did in the previous one, in terms of C. So when I divide this, I'll get this is 0.0004 IB. Actually, wait, because I want this in terms of C. So I'm actually gonna multiply each side by 100. So cancels here. So I get 100 C is equal to 0.004 B. Divide each side by 0.004. And that will give me 25,000 C is equal to B. Okay, and then I have my A and B value, and I'm asked for A plus B. So A plus B will be 66C plus 25,000 C, which is 25,066 C, which again looks like answer choice A. Okay, and let's look at one more percent problem. Okay, so this one. The composition of an animal is defined as the muscles, bones, and fat of the animal. A scientist studied the composition of young one young swamp buffalo and determined the buffalo had 133 kilograms of muscle, which made up approximately 65.9% of its composition. Of the remaining composition of this buffalo, approximately 46.2% was bone, and the remainder was fat. Based on these approximations to the nearest tenth, how many kilograms of this buffalo composition was bone? Okay, so first, I need to do kind of what I did with the couple problems go. Put total weight. I always just put it as T, total weight. So I know that 65.9% of the total weight was made of muscle, and that was equal to 133 kilograms. So I can actually find what the total weight of this buffalo was by dividing each side by 0.659, and this will give me, let's see, 133 divided by 0.659. It's like 201.8 kilograms. So that's the total weight of the buffalo. So the remaining composition, I'll take the total. So 201.8 minus 133 is equal to like 68.82. That's what left of the remaining composition. Okay, because it says of the remaining composition of the buffalo, approximately 46.2% was bone. So this multiplied by 0.462 will be made up of bone. And when I multiply that, that gives me 31.8 kilograms. And then I have my answer. Okay, if you see just always percent problems, just be familiar with them, read them super carefully so that you don't do any missteps along the way. And then you'll have the answer. Okay. So those are my predictions. Be really familiar with factoring, with no solutions, with percents and equivalent expressions. Those seem to be the most common concepts or most difficult concepts that come up on the exam that students have struggled with. Also refer to my May 2024 predictions. I made that one a couple of weeks ago before the May SAT. And students reported back to me that some of those questions or similar variations of them appeared on their exam. So both May and June predictions, I think, can be extremely helpful for this June SAT exam. Okay, so I hope this video is super helpful, and I hope you see very similar questions on the exam and you know how to solve them. And yes, like, rate, subscribe if you like this video and you want to see more of them. I will keep making more of them because I want you to get a perfect score on the SAT. Okay, so guys, it's been fun. I'll see you in the next video. And if you check out below in where I put the information of the video below, there's a form if you want to fill it out with any special requests that you want to see in a video. I'll be happy to make it for you. Okay, so if you're taking the June SAT, good luck. I hope you do amazing, and I hope that this video and my May video too helps you get a really good and amazing score. Good luck.